Is one day after Christmas 2025. Max is given this problem. We're trying to understand volts, amps, and resistance. So we have two equal water tanks, two water pipes. One, the hole is only 5 opening, and the other hole is 10 opening. So we know that this pipe.
5 miles per hour, and this one goes 10.
Okay. So the question is, which one of these pipes are going to deliver the water to fill up the tank? These are even tanks. Which one's going to fill up faster?
In my opinion, they'll probably go the same because this is 5 and 10, but this is 10 and 5.
Okay, so the water is going to fill up exactly the same time, even though this has a bigger pipe.
There's a chance, yeah.
Okay, so the answer is correct. So even though this is a smaller pipe, the water flowing through it is going double the speed. Even though this pipe is much thicker, the water that's going through it, even though it has a large quantity, is going slower. So at the end of the day, they fill up the same. So now, which one is the volts in this analogy? Is it the 10 miles an hour?
10 miles.
Okay.
Amps is the amount. Resistance is like how much it's pushing back.
Yeah, so this is the screw handle. If I tighten this screw handle tighter and tighter,
that's resistance, so it stops.
So what happens if I have the resistance all the way down? What happens to the flow of water?
It'll stop because that right there will clamp down
and no more blue water will cross.
Or brown.
Okay, so
or green.
So what do you say? What are the voltages?
What?
What is the voltage in electricity?
Speed.
Okay, or the pressure of the water.
Yeah. And then amps is a good part because it's how much is. So it can become big back. And resistance is basically when you turn this, it stops and then stops the water. So like it's how much it's like stopping the thing.
Okay, so I'm gonna add to that. When this thing is all the way up, the resistance is considered low.
Very low.
If the lever is twisted all the way down, so this thing, this is high. Now, that's resistance. I'm going to add to this word. There's another symbol that looks like resistance. It looks like this. The word is called omega. Another word for it is called is ohms.
Guys, always watch this when you're like young. You can't watch it when you're old because when you're young, you learn faster.
Okay, so resistance, what's another two names for it? Ohms?
Or
omega. Okay. It all means what?
How much it's pushing. How much it's stopping.
How much is stopping the flow of what?
Of electricity.
Electricity.
Water.
Okay. So the water is an analogy to electricity. What's this analogy? It works similar. So we're using it as an example, an analogy to explaining how electricity works.
Electricity goes way faster.
It is.
And it can probably bypass metal. No, it's probably just going to go into the metal.
Okay, so now that you understand these words, I'm going to ask you one more time. What is voltage?
Voltage is pressure.
Okay, so how fast this water is gushing out?
10 miles. That's 10 pressure.
That's just the speed. That's like the push of the water coming out. So what happens if I change this from 10 to 100?
What?
What happens if I change the water going at 10 miles an hour to 100 miles an hour?
And then if it's going to go like that, it's not even going to go inside the cup. It's going to go outside.
It's going to shoot really far.
Into the other hose.
Okay, let's just say it was 10 miles an hour and I put my hand on it and I stopped the water. What happens if I change it to 100 miles an hour and I put my hand in front of it?
It's going to start hurting and it's going to spray upwards, downwards, and sideways, and diagonal and
Okay, it's gonna start hurting. So what happens if I change the water to 200 miles an hour? That's the speed of a Lamborghini. If you put your hand in front of that water, what would it do to your hand?
it'll hurt it really bad, like a high pressure water. The things where you like do the roads that are super stained,
Okay.
high pressure water.
Did you know water can actually cut steel?
Yeah, if you do it fast enough.
Yes. Very precise and very high pressure. You can cut through metal.
That I think.
So at the end of the day, when the voltage is higher,
I see water cut.
it can do. It's more pressure. And I think a human being can feel something when it hits like, I'm just going to throw a number like 40 volts. We're going to have to Google that, but some number like that. 40 volts, you might be able to feel it. Now hold on. At 12 volts, which is a car battery, you cannot feel 12 volts. So if you take your hand to the car and you see the battery has positive, negative, and you take both fingers and you touch on one side and the other side, can you feel 12 volts?
No.
Cannot. Why does electricity not go through 12 volts?
Because it's too little.
It's too little. So here, this go ahead.
How much volts is when you like touch something and it shocks you? Like when you normally touch something and it shocks you.
I would say something like 60 volts and higher. But right now, in these outlets, they have a certain number.
100.
120.
I was so close back.
You're very close.
Let me.
Okay. So when you have an outlet, it looks like this. Like that.
I thought that was the thing you plug into.
Yeah. One side here and one side here together, it has 120 volts. And if you put your hand in these two wires, you can feel the 120 volts.
How about the bottom?
The bottom is zero. It's ground. It's a zero number.
Why is it even there then?
I'll explain to you that in a little bit too. But ultimately, if it has 12 volts, you can't feel it.
But
The voltage has to go higher.
120 is
Yeah, then you can feel it.
a lot.
Yes. All right. So now we're going to go move over to a circuit. So I wanted to teach you 4 words: volts, amps, resistance, and one more is called circuit.
The circuit was like the wire.
That's it. Circuit. The main word in a circuit is a circle.
Because there's a circle and there's wires in the circle.
So if you have a circle, then you have a circuit. If you don't have, if it's like this, is that a circuit?
No.
There's a name for it. Right here, it's called open. Because it's not closed. Open. If it's open, we call it open.
Circuit.
Exactly.
We're back. Oh, open.
Now, if it's closed, then it's called
Circle.
closed circuit.
That circle does not look like a circle. It looks more like a O or a 0.
Yeah. But at the end of the day, it starts to sun someplace, goes someplace, and comes right back to the same thing. So that's closed circuit. All right. So I'm going to start a new page. Now, I'm going to draw you a circuit like this.
That's big for a circuit.
Okay. Then on this side, I'm going to put some coils here.
That's coil of.
So this circuit, this copper line basically becomes a whole bunch of twisty copper lines and ends up right here. Yeah? All right. And then over here, I'm gonna have over here, I'm gonna have
Sorry, people. I need some water. I need some milk.
so the purpose of this screen is to teach you how electricity is created.
It's using you can use a solar panel. No, you can use a sun, a magnet, or nothing.
Okay. So I have a magnet here, and I want you to explain me how I can get electricity in this circuit.
Somehow you're supposed to move it.
Okay, so let's say it's able to move. I'm not saying how it moves, but let's just say it can move. So draw some rotation.
Guys, it doesn't even have to be touching. When you move it, the electricity are gonna go in there, and the size of which side you're moving it, and then it can go that side. Oh, I'm gonna go this way.
Okay, so what you're telling me is you are asking it to spin clockwise. So you're spinning it this way, right?
That was the other way I was gonna say, but okay.
Okay, so basically, if you're telling me you're spinning, that means that this north is going to become closer to the coil, right? And the next second it's going to go away, and then the south side is going to get close to the coil. Is that what you're saying?
What? Yeah.
It's spinning.
Yeah.
So this blue side is going to be close, and then as it spins, the blue side is going to be away, and the red side is going to be closer. Okay, so every time that happened, there's magnetism inside here.
And magnetism makes your
Okay, so magnetism is basically going into this coil, and that's where there's already electrons in here. Electrons are electricity. They're just already there. They're sitting inside the atoms. But because you're pushing the electrons one way and you're pulling the electron one way, it's gonna make the electrons start doing what?
electricity.
They're gonna start flowing.
Guys, look at this.
Okay, so here.
Wait, guys, look at this. I did not. Okay, just give me
Undo.
undo. I want to erase this part. Okay, I'm just gonna draw another one. No, so bad. Sorry, guys. I just want to draw. I'm totally not trying to waste your time. Alright, boom. See that right there? And then boom. Imagine this as the wire. And then light. When you put the electricity, just to tell you. Wait, no. Boom, right. I love it.
Okay. So let me finish your train of thought, okay?
Animation.
So inside here, before this magnet is moving, the electrons are just staying very still. They're just in there. But because the magnet pushes the electrons to flow one way, and then when you get to the opposite side of the magnet, it pulls it back. So this is what its electrons are doing at the same time. They're moving this way, and they're also moving back the other way. So when electrons are moving in and out of the wire, that type of movement has a name. It's called AC.
Oh yeah, guys. The electricity that goes in here becomes heat and it disappears.
That's right.
That's just how you guys.
But remember, what's the rule of energy? It cannot never be created or destroyed.
Like atoms. Well, no, atoms you can't destroy.
It just changes forms. So the electricity that was in the wire, it comes into the light bulb and it changes itself to
Heat.
heat and also
Light.
light, so you can see it.
It's not getting destroyed, but
It's just changing forms.
turning into a different atom.
Okay, so now, if the electricity is being pushed out and pulled in, what's that type of current called?
Magnetism. No,
AC. This is the name for AC. AC stands for, A stands for alternating. C stands for, guess what? Current.
So alternating current.
Alternating current means electricity that's moving and coming back. In America, we have a particular time that it has to happen. In America, it's called 1 hertz.
Max.
And that hertz follows a certain beat. In America, it happens at 60 hertz. What does that mean? What does 60 hertz mean?
60 hertz.
What is 1 hertz? What is 1 hertz?
1 hertz.
That means 1 second. So when I say 60 hertz, that means this electricity that's being pushed and pulled is going through the light bulb and back out, through the light bulb, back out. In 1 second, it does it 60 times.
That's what I'm about to say, but okay.
Okay. In another country, say for example, Vietnam, it could be happening at 50. So what does 50 hertz mean?
50 in 1 second. 50 volts been hurt.
That means that the electricity has moved in and out 50 times in a second.
Yeah.
So that's what it means. And what happens if I tell you that this generation of power can make 120 volts?
That's a lot.
Okay, so what happens if I don't put a light bulb here, but I put a coil? Then what happens?
Then it's just gonna turn into something.
Let's say I make a coil right here. This is the magic part. What happens if I put another circuit right next to it? Then I put another coil over here. What happens to the electricity that's traveling in here?
You don't have anything like rubber to stop the electricity to go somewhere. So, and then it's gonna float and go into the other one and make electricity there.
That's correct. So what you're saying is this thing is called a conductor, and usually wires have insulators to stop when you touch it, you don't get electrocuted. So you're trying to say that there's no insulators here, nothing in between, right?
Imagine if there was.
Okay. So my question to you is, you just told me that electricity that's from here, the electricity that's traveling in here is going to make it on this side. So did it jump over, or how did it make it over there?
It jumped.
No.
It floated. It used its magical powers.
The electricity here didn't float over. How did it get over there?
Magical powers.
What caused it to be made in the first place?
Magnet.
Which is magnetism.
Yeah.
Magnetism is an invisible force that pushes and pulls electrons.
Well, you want to say.
So this is the same. this is a very important concept. Once you get this, then we're done. Remember I told you the electrons are sitting inside here? Well, it's the same thing. Electrons are sitting right in here. But the only difference now is this electron, because of this magnet, is pulling the electrons this way and pushing it back. And that is the same concept as...
Wait, I have a question. Can this pull back the electricity to over there?
Yes, it could. Now, this is the main thing that you need to get. Because if you don't get this part...
Don't get any part.
No, you got a lot already. But this is the last concept. If you can get this, then you're home free. Are you ready?
Yeah.
You've already guessed that the electrons here jumped over. And that's how it got to the second circuit. This is the first circuit, number 1 circuit. This is the number 2 circuit. And you told me that your guess is it jumped over.
Or use its
Which is a very great guess.
Or use its magical powers to go over.
Okay, so what happens here, in reality, is right here. Remember I told you the north side got close and then the south side got close? Well, every time one side gets close, it either pushes the electrons out of the wire or move it out of this wire to the, not out of the wire, but moved it along the wire. And when it got to the other side, it pulled it back. So these electrons, you see these yellow things? They're doing exactly that. 60 seconds. In 1 second, it's going this way, and the other second is moving back the other way. So it's creating magnetism right here. So magnetism is happening.
And it goes over there.
Yeah, and then the other way, the magnetism is pulling it back. So all these electrons in here, they're getting pushed out and then pull back. Push out and pull back.
Go back over there.
At this moment, yeah, at the moment, let's just focus on this. Look.
Mom, I made a portable thing.
Max, you're very close. Just stay with me so I can eat. So it moved this way, and then when the magnet pulled the other way, it pulls the electron back, and then the electrons go the other way. So they go this way, then they went this way, then they went that way.
Uh-huh.
So in this particular box, this particular box, this union right here, there's a name for it.
Soviet Union.
This is the last word I'm going to teach you today. It's a very... What's that movie with the robots that can change from automobiles to robots?
Transformers.
That's it. This box is called a transformer. For example, if it had 120 volts on this side, it could bring it either up or down
It's over there.
to say 240.
Uh-huh.
But remember, we get nothing for free in the world. So if I had 120 volts, this is the last one. If this is 120 volt at say 20 amps.
So 20 rounds a second.
Over here, I got double this. Then my amps are going to be half of it. It's going to be 10 amps.
That's kind of...
I mean, you remember what amps are, right?
Yeah,
The
each second it goes around 10 times.
No, that's hertz. Amps is, remember the...
Oh, yeah, pressure.
No, pressure is volts.
Amount.
Amount. So basically, you had 120 volts of pressure at 20 amount. When you go through the transformer, now you have a lot more pressure, but you have half the amount.
Uh-huh.
So doesn't that make sense? Because you don't get nothing for free. If you get more volts, you have to less.
Over there, you got less amps.
Yes. And that's the end of electricity. If you understand this, then you can explain me a lot about electricity. Okay, come back. Come back. Give me 1 or 2 minutes of explanation of all of this. What did you just learn? Start from the magnet.
With the magnet, if you turn it away, it's gonna...
Stand up here and point to what you're saying.
So you have the magnet. You can turn it away, and it's gonna go into the copper wire, and it's gonna go there, and then gonna go back. But if you add one of these,
Hold on. Let me straighten your thought. the electrons are already sitting in the copper wire. Because of the magnetism, it pushes the electrons to move in the copper wire.
So it pushes the electricity to go to over here,
Mm-hmm.
and then that
Wait. Once it pushes, what else is the magnet's gonna do?
it's gonna push it back and pull it.
Yeah, push and pull.
Push and pull a lot of 20 times a second. No, 20.
60 times a second,
60 times a second.
which is called 60 hertz.
60 hertz. In this place, there's it's making
Magnetism is making magnetism.
magnetism, and then the electricity is going over here. But
The magnetism is going over here from one side to the other side.
one side to the other side.
And what causes, when the magnetism hits this wire, there's also electrons sitting there doing nothing. What happens to the electrons in this wire, in the circuit?
It becomes double it, but
No, not yet. You just have to explain the flow in it first.
it's gonna go.
Make the electrons flow,
It's gonna make the electrons flow and come back.
right?
And life isn't free, so it will. If you're gonna double this, you're gonna get less of those. So it's gonna be 10, and this is gonna be 240. This is gonna be 120, and this one's gonna be 20.
Okay.
And then if you go into here,
So what's this whole box called? What is that?
transform. So if the electricity go over here, I like made the picture.
Mm-hmm.
So when it goes into here and comes out, well, it's probably not gonna come out.
So you drew a picture of a what?
Copper wire.
But what is this whole mechanism called? It's called a light bulb. Okay, so you drew a light bulb.
So electricity.
A light bulb is out of those 4 words: circuit, volts, amps, and resistance. What is a light bulb?
A open.
It's a resistance.
It's a resistance.
It's stopping electricity from flowing.
So So electricity goes here into the light bulb and the copper wire and then the electricity, because there's nothing. Wait, there is something stopping it. So the electricity.
So I don't think I drew you a picture of what a light inside a light bulb
Oh,
is.
wait. Listen.
Okay, go
So
ahead.
the electricity goes inside here and it shoots out and turns into heat and light.
Got it. Okay, so let me finish your concept of a light bulb, okay? So this light bulb here, it has thin wires that are inside. And these wires are very thick. Okay, so these are very thin. When the electricity that's going through a thick wire, it has to be pushed inside a thin wire. All these electrons that are going, they have to all go in here and come out. So inside here, it's going to get hot.
And then it's gonna make heat and light.
Exactly. Heat and light come out.
Alright, bye.
So if this is a thick wire and this is a very thin wire, what happened? You just resisted electricity. That's called resistance.
Super fast. With amps, I think.
Okay. So what's the last thing? What's the word called when it is resistance? What's another name for resistance?
Omega and
Oh.
and omega.
And
Ohms.
ohms. That's it. They all mean the same thing. All right. Good job.